A rat uterus was isolated and used for this experiment. Measurements were done using a force transducer.
During normal contraction, calcium enters the muscle through the activated voltage-gated L-type calcium channels. Once inside the cell, calcium ions activate the release of calcium from the sarcoplasmic reticulum, further increasing the calcium concentration inside the smooth muscle cell. 4 calcium ions then bind to calmodulin, which then increases the activity of myosin light chain kinase. Using ATP, myosin light chain kinase phosphorylates inactive myosin into its activated form. The phosphorylated myosin then leads to contraction of the uterus by forming a cross bridge with actin filament.
After taking a control, 10 drops of 2% lidocaine was applied to the uterus. Lidocaine is commonly used as a local anesthetic. It will inhibit smooth contraction by preventing the influx of calcium ions into the smooth muscle cell. The result is reduced contraction in the uterus.
Another control is taken and 2 milliliters of 10 millimolar sodium nitroprusside, or SMP, is applied to the uterus. SMP is a known vasodilator. When it is applied to the uterus, it breaks down to nitric oxide. Nitric oxide activates guanylate cyclase, which converts GTP to cGMP. cGMP activates protein kinase G, which then activates the myosin light chain phosphatase. This activated phosphatase inactivates the myosin by dephosphorylating it. This in turn causes a decrease in the strength of smooth muscle.
After taking a third control, 10 drops of 0.5 millimolar verapamil was applied to the uterus. Verapamil blocks the L-type calcium channels, causing an inhibition of calcium influx. No calcium enters the cell, preventing the phosphorylation of myosin and stopping contractions.